CMG Technologies are MIM specialists. But what exactly is MIM? Metal injection molding combines the design freedom and ease of plastic injection molding with the strength and performance of metal. The process begins with the preparation of the raw material feedstock. This stage enables the manipulation of metal or ceramic powders to behave like a plastic by mixing them with an organic polymer binder system, so that high-density, complex parts can be produced to their net shape and to tight tolerances. The metal powders and binders are blended at temperature to create a homogeneous mix. The mix is then fed into a pelletizing machine, which processes the material into pellets of uniform consistency that can be molded, like plastic, into complex net-shaped components. The customer's dedicated tooling is loaded into standard molding machines, of which we have a range varying from 15 tons to 60 tons to ensure the optimum force is used for varying sizes of components. The feedstock is loaded into the feed hopper, and as it passes into the machine, it's heated just enough for its consistency to become very similar to molten plastic, before it's injected into the bespoke tool. Due to the nature of the process, complex 3D geometries can be achieved, and details can be molded into the part, such as knurling, internal and external threads, blind or through holes, and logos. Once molded, the part is referred to as a green component. After molding, the binders must be removed through a debinding process. The components are placed on ceramic trays and loaded into a debind oven, where they're thermally debound at controlled, ramped-up temperatures. Once debound, the parts are very brittle and porous, as only one binder remains, and they're referred to as brown components. The brown parts are then transferred to the final stage of the process, where they're sintered in a controlled atmosphere. Air inside the furnace is replaced with hydrogen or argon to avoid metal oxidation, and temperatures are precisely raised to just below the material's melting point, where the particles fuse. This causes shrinkage to occur at an average of around 15%, and the component densifies to its intended parameters. Density is now comparable to a wrought or cast component, and like machined parts, can also be heat-treated, welded, or plated. Further processing is not normally required, as parts are accurate to plus or minus 0.5% of a dimension, though this can be increased through mold tool development and secondary operations if necessary. We work with many materials, including various grades of stainless steel, Kovar, nickel iron, copper, and ceramic. Others, which can be hard to process, such as Hastelloy or Inconel, are no more difficult for us than more widely used materials. And now, we can even mold titanium. The list of sectors that utilize our process is long and includes the medical, aerospace and automotive industries, where MIM is now becoming accepted as the default manufacturing option. We are highly experienced in the manufacture of MIM components, and as such, we're a global supplier, working with major blue-chip companies worldwide. CMG Technologies, MIM specialists.